Okay, my presentation is on measurement invariance as part of the measurement invariance methodology industry, so to speak, in cross-cultural and comparative research. And I will bring some arguments and discuss also the controversies, especially at the end. But especially I want to present some new procedures which deviate from the way measurement invariance has been tested in the classical literature, which seem to be more adequate. Okay, so that's my general approach, so to speak. And I'm very happy to be here because in a lot of conferences I've been in my life, it's often just often boring. Now this time it is interesting. It is controversial. So this is really good, I must say. This is my first personal statement. Okay, even if we have different opinions, and with Boris, myself, also partly the same and different, but you will see. Okay. I firstly give you a short summary of the general approach. I know that a lot knows something about it, but not everybody. So I will be short, sweet, and to the point. And it is also relevant because of some of the arguments of Chris, I think. And then I will show you 3 studies, because I suffered from the same problem that nothing worked in the ESS, so to speak. And we had a lot of problems also to convince Shalom to start, because he was, to say the least, astonished or frustrated, firstly, about the results. I firstly give an example, which is a simple one: attitude toward immigration in the European Social Survey. The next one is a revised value scale with 19 values, which is a more complex measurement model, not only with one construct, but with 19. And the last one is is a simple scale, but this was a real goal of me to say to all my colleagues, in principle, when we take the measurement invariance business serious, and we want to exploit all these big, lovely data-generating programs like World Value Study, ESS, and so on, then we must not only, like people now do, test over countries, but also over time, when we take the idea serious. And then I had a lot of problems, I will show you, to do it, even with one scale with 3 items, with a new procedure in M+. Okay, so this has also practical implications even when one is doing it. This is my message also. And then I will, in the outlook, discuss what is in the moment my evaluation of this so-called approximate measurement invariance instead of the exact one, using the Bayesian approach. I will less talk because of time about alignment, which is a different procedure, also available, more, let's say, explorative. I will also discuss robustness checks, which is a new topic now taken up by statisticians, because they do what Chris has done also. They say, it's not only a 0-1 decision, we have to see how worse our sins are. That is, in the sense, is it really so relevant when we even falsify the assumption, when the mean differences are still not so big? But this is still in the beginning. And then I have still problems with Chris' argument about macro and micro. I thought, I would say, the goal of sociology is certainly not to be an aggregate psychology. This is a Coleman dictum from Jim Coleman. So we have to do multi-level analysis. But when we do multi-level analysis and use at least individual dependent variables, and then use also independent individual variables, then I think we have a problem with measurement invariance, so we have to take it into account. But certainly we should do multi-level analysis using contextual variables. We can also use it, by the way, to look for reasons of non-invariance. We have started this research also a little bit. Okay, well, that's maybe a long story, now I have to be shorter. So, in general, the psychometric point of view had been always the question is measurement invariant when it measures the same construct in the same way across different groups, whether it's countries, cultures, or geographic regions. Now, it's a precondition, and now there's a very important issue. Why do we do it all this? Because it was Meredith, I think he was the first, in 93 to show that both our regression coefficients and our means are biased when regression coefficients are biased when metric invariance is not given, and our means are biased on the individual level when scalar invariance is not given. This proof has not been refuted till now in 93. It was elaborated by Millsap in a book only on measurement invariance, and Gouenol and Brown in 2015 show again for regression analysis how the, let's say, violation influences regression coefficients, so that one sees concretely with Monte Carlo simulations in a different type of situations. It's in a new book on measurement invariance. Okay, what are the approaches? You see, we have different ones. Assuming is in statistics an old tradition, but like multivariate normality, but it may be dangerous when you have bias there. Empirical assessment. We can try to use the technique like multi-group factor analysis and check for full measurement invariance. Full in the sense metric or scalar. But this was seldom done, but when it was done, often failed. Now, in case of lack of measurement invariance, we could look for partial. That is, two items are enough to establish still measurement invariance. Was shown by Byrne, Schaeffelson, and Mutane in '89. We can also, but this is not good in principle because we lose information. So a lot of cross-cultural researchers would say, Peter, no, that's not a good strategy. Drop groups or items. And we can refrain from gross group comparison, but this would be really the worst. It would be idiotic, so to speak. But one could also look for alternative appropriate methods to assess gross group invariance and checking for robustness. The new papers which I recommend are by Oberski in Political Analysis 2014 and by Kuha and Mustaki in Psychological Methods 2015, who have written on this robustness issue. Now we look for these alternative methods now, not only for partial invariance in my example. The classical way, most of you may know, so I just repeat for those who don't know maybe, is we have two latent variables. We have maybe Germany and Russia, and then we look whether the regression coefficients and the intercepts are the same in the two countries. That is, the betas are the regression coefficients, that metric invariance, and the alphas here, these are the constants. This is scalar invariance. So this would be for the mean comparison. And we evaluate normally by CFI differences because it's a more liberal criterion than the chi-square difference test. Now, what are alternatives? Newly developed was by Mutane and Asperov, implemented in M+ now, but maybe in Lavan they work on it also, is instead of exact measurement invariance to take up the evasion ideas, that is, which is also discussed in sociological methods and research for sociological theories. Because in the normal statistics it's very inflexible. They don't take into account the stochastics. That is, that we often don't think the coefficient is 0.5. There may be some wiggle room, or we are happy when it's positive in all cultures. So to take this into account, one can take this Bayesian approach. Also, there has been some ideas by Zaris Satora based on local misspecification, but I leave out this here because of the time. Now, similar assumptions in both approaches allowing for some small deviation. So that's the idea, to take into account the stochastic character. Now, Zaris' proposal was to rely on modification indices, but to take into account the power also, which is normally not done in SEM, to take into account the power to get the right modifications. And the size of the misspecification is defined by the researcher. Yeah? The specifications are here said, but I don't want to go too much into it. Let's go now to the first practical example. Now, I was involved also in the revision of the module on immigration attitudes for the ESS, which is now available. And so we said people will criticize us when we don't apply our methodology to our own data sets. People will say we are not credible. So we looked at the core items, attitude toward immigration in the European Social Survey. We now try to test all the others too. And this was a team who was doing it in study 1. And we used total of 35 countries, 6 rounds of the ESS are included in the study. Not all countries participated, some joined early and so on. Other countries were not part. Table 1 summarizes now the number of participants, which is coming in each round, percentage of female respondents, mean and standard deviations, and data in each country included both respondents with and without immigration background. Okay, but we did out the immigration people. Thus the total sample size was 271,220 respondents. You can get also the data there if you want to reanalyze it. Okay. 3 items measured attitudes toward immigration. These are the core items which are replicated every round. And they asked whether respondents prefer their country to allow more or fewer immigrants, a hot topic in the moment in Europe, as you all know, who belong to a certain group to come into the country. So these are the questions. The first group consists of people of the same race or ethnic group from the country. The second group consists of people of a different race or ethnic group. And the third consists of people from poorer countries outside Europe. So we have now in the new one also a question about Muslim, because it makes it maybe more relevant in today's time. You see here now the data and measures. You see here the different rounds, 1, 2, 3, 4, 5, 6. And you see, just take Austria as the first country here, the sample size, percent of females, mean, and for all rounds. So I don't go into it. You see, in principle, that's how it works. And for the next countries here, Germany, also here in Latvia, Israel, and so on. And here you see Russia. Here it is, there. It started in the 3rd round. Okay. Now, what was the plan of the analysis to do it? First, we ran 6 multi-group confirmatory factor analysis using the full information maximum likelihood procedure to take into account missing values in an optimal way. 1 for each round with all the countries included in this round. And this was a discussion between our team. You see, I said this is still not honest, to be honest. Because we test now only for the separate rounds and not over all rounds. You will see. I did it in the last paper only. Because we had, they said, Peter, that's too much. People will not see, understand it, and so on. Okay. Each analysis contains 3 assessments for configurable metric and scalar equivalence, respectively, with the corresponding constraints. And to identify this in more technical thing, maybe for only for those who are interested in MGCFA. It turned out that the loading and or intercept of these items, I mean, testing for exact full or partial scalar equivalence was the first step. Yeah. And if it turned out that loading or intercept of this item varied considerably across countries, we used a different reference item for identification. And when full measurement equivalence was not established, we tried to assess partial, that is to do out one item, because when they are reflective, that's the advantage, they are interchangeable, as Boris said, you too, there is no difference between us. We used a G rule, but because of time I don't go into the G rule results so much. Okay, in order to establish partial scalar equivalence, which is normally the worst, I mean the most difficult. Have time. Okay, yeah, this is okay. Yeah, I hope. Only one item could be released because partial scalar equivalence requires that parameters of at least 2 items are constrained. We can use G rule for misspecification choice. but this indicated that in these countries even partial scalar equivalence could not be established. So we had a problem there, which means problem of comparing means when we take the methodology serious. Okay, now when we switched therefore from exact measurement invariance, which has been the tradition till now in psychology and in sociology not so much, to Bayesian, because it is more flexible. It is shown by Monte Carlo simulations. And then the average difference between loadings and intercepts across countries is assumed to be 0 when one tests for exact measurement equivalence, whereas in Bayesian you allow for a certain wiggle room, so to speak, a stochastic component, which is also a point of criticism whether this is ad hoc, so to speak, how to decide on this wiggle room. Yeah? Van demonstrated using simulation studies that variance as large as 0.05 imposed on the difference between the loadings or the intercepts across countries does not lead to biased conclusions when approximate equivalence is assessed. We followed their recommendation and used this as a so-called prior in the Bayesian analysis. Use similar constraints, okay, and these are the more technical things. And now again the model here. You see here this is a very simple model with one latent variable and 3 items. It's a reflective model, which was then tested in every round separately. Now let's look at the results. Global fit measures for the exact measurement equivalence test. And you see here for the first, for the configural and metric, it is okay in the first round, but for the and for the partial scalar, the CFI was also okay. For the second round was also okay, but these are simple scales, so to speak, only with 3 items, so it's an easier job. And then we go on with the 4th and the 5th round. You see again when you look at the last column that at least the CFIs are rather okay, but you see at least when we take serious the rule of Chen to take a 0.01 difference as a significant difference, then from configural, which is top as a baseline model, to the next one, it becomes worse. So even the metric is not really, from strictly statistical point of view, acceptable. And the same happened with all others. So when we take the criteria which are in the literature, the exact would, although the values are good, it would not be to be accepted. Okay, and countries I leave out here. This is a SARIS analysis, but now we look at the fit measure of the approximate measurement equivalence model, and there we have different fit measures, and they should be higher than 0.0. So you see they are all okay. So when we introduce this wiggle room, it seems to work for this scale at least in every round separately. But you see, I still have not done the full job, because I would have to check also over the different rounds. These results are always separately for every round. But when I now use data from World Value Study or ESS and have several rounds, in principle, I must also establish not only equivalence over countries, but also over time points. Okay, results. Now, an interesting point was how high is the correlation of country rankings, because often they are used in a lot of publications, based on the 3 methods: exact equivalence, approximate equivalence, and raw scores. And you see the correlation between exact and approximate, although exact was wrong, is rather high. The rank order is not much changing. So that's an interesting check for robustness. And even when we use raw scores, the correlation is still in the rank order high. So at least for this simple example, the robustness check shows even if we violate, okay, it's a problem. Not a problem, so to speak, sorry. Now the next one is a more complex model, because we have now the Schwartz value And we had a disappointing result in the ESS at the beginning because firstly we did not find 10 constructs but only 7 because some were too highly correlated, and also the scalar invariance was not given at all. So we said to Shalom, stop to compare means. He said, what? Impossible. This is not, whatever you tell me, this is not good. So what to do? Okay, but we published it firstly. At least we wanted to be honest, and after a lot of discussions in the Public Opinion Quarterly. Anyway, we did then some more analysis and tried to find out reasons why there was lack of scalar measurement invariance. And Shalom revised the instrument. Now he has 19 values, and there was an encouraging result, but not with representative data. So I may only show. You see these are the 19 values. You see how complex the job is. When you want to test for 19 values, you could also test for higher order. But in contrast to Chris, that's also an interesting difference. Shalom and would argue in the Swiss Journal of Psychology, or Davidov and Chichuk and Shalom, that they think it's a higher order factor model, a hierarchical one, like Boris was presenting. Because of theoretical reasons, you see. He would not use a formative model, but a hierarchical one for the relation between the lower order factors and the higher order factors. But it's a question of theoretical thinking. One cannot prove it easily. Okay, now you see here's a sample, 8 countries, not big samples, but at least one can use it for a test for the 19 values. And to make a long story short, one got encouraging results for the exact MGCFA, but then for the scalar invariance, also for the approximate method. And so I may go, you see, full or partial scalar invariance, but not for all values. 10 of 19, you see, was scalar. Metric was not a problem. Equal loadings, but scalar is still also here a problem. Maybe you see metric, okay, scalar is a problem in this analysis. Better than with the earlier P4Q version, but there is still room to say it nicely for improvement because of this situation. Is the test too strict? And therefore we allowed for small deviation in the Bayesian approach, again here, and used also the G rule for this purpose, but I have to be now a little bit, I leave out the G rule part and go directly to the results.
You still have 7 minutes.
7 minutes, yeah. Okay, now I have to study 3. That's the reason this will also have some chance. Here we have the summary for exact and for approximate invariance, so to speak. You see here for the different countries, and then you see also here for the different values, for example, self-determination thought, self-determination action, stimulation, hedonism, for example. And you see here full scalar MI are 2 stars, partial scalar 1 star, and lag is a minus. So you see a mixed pattern here for all these countries. Here we have lovely, okay. So you see for some it works, but not for all. And here we have for achievement and power and different aspects of power. Then we did self-enhancement, Bayesian analysis, the result shows when you look at the PPP value, which is a goodness of fit, and this one should include a 0, which is the case, and it's higher than 0.0, is the case too, then it worked out for achievement, power, and dominance and resources. And here is again for the exact results, conservation also, and here for the other countries, you see again mixed picture. Maybe I should leave this so far and go now to the next and last study. 5 minutes, so I should be short, sweet, and to the point, and come to my conclusions. This was now the study I always plead to do. That is, in principle, when you take the measurement model people serious, or confirmatory factor analysis people, then you have at least two problems. One is, it's not only one latent variable, but several. So you have to check 10 factors or 6 factors, possible cross-loadings, error correlations. This is one thing, which makes the work complex. And the other thing is that you have overtime. Here I analyzed the overtime problem together with a doctoral student in Giessen. And you see now I used both the different rounds and the countries, firstly separately and then simultaneously. But the problem was that even with 4 items, it was a universalism scale, we needed, I think Boris had similar experience, with 4 items, 1 day of computing time. And when I had 10 scales, it was 1 week. So I will write again to M+, they have to make the algorithm much more efficient, because this is really a problem of this approach. Now practically, I always try to do things practically, that is to apply whether they work. And in principle, here, this was, we use the following, the same procedure as in the other paper, configural metric scalar, partial scalar, traditional, and setting different informative priors for the approximate approach, releasing constraints on those loadings and intercepts which are different. And as additional steps, we had even in the Bayesian approach to delete groups. So we started with 90 groups, 15 countries, times 6 time points gives 90. Now in the world value study, I would have to multiply, I think, maybe 60 countries or 70 times, I don't know, 6. So I come up with much higher number even. So this what we did, and you see here that we have here configural round 1 metric scalar, partial scalar, metrics and scalar, and so on for the different runs. And then the important thing is you have here always the different rounds. Round 1, round 2, round 3, round 4, round 5. This was like in the first paper, separately tested for every round. This looked not bad, but the real problem was when we do it all rounds simultaneously, then the fit became much worse. So this is also shows the practical problems, even with Bayesian. Here we still have all countries, but when we used then take into account the fit, then we came up with, I think, 72 countries from 90 which we could compare, which is not bad, but still not the ideal for a cross-cultural methodologist or researcher. This is a relationship between some scores and scores on Bayesian. You see there is some bias, downward bias, and I leave out maybe the global fit measures, but here you see again that the PPP only for the 90 groups was 0, so not acceptable. So we had to give up certain groups, and then it was higher than 0.0. So these are the correlations between some scores, again like before, between latent means computed using some scores, the exact and the approximate means. You see still it is rather high for the exact and the approximate, but much lower for the raw scores or composite scores. Conclusion. Bayesian analysis are promising, but still have to be developed for really situations like in world value study and ESS, when we have more complex analysis. They suggest approximate invariance when stricter methods rejected, but one needs now studies with groups higher than 100, and one would need also robustness studies in general to see how much our regression coefficients in a multi-level model or a normal regression model, in a polynomial, in a logit model, would be biased, given that these assumptions are not given. So to finish, I think where I still have a problem of understanding with this macro, I like this macro, micro issue very much. I think it's very central in methodology for sociology. But I thought, when I look at most of the analysis in ESR or other other journals, then I see the multi-level analysis have mostly contextual variables, individual variables, and then individual dependent variables. So when you have individual dependent variables and you have individual independent variables, then I would not say we can so easily give up the assumption or the test of invariance, maybe with more liberal methods, to establish when there is a considerable bias in our coefficients. So this would be still my message. I don't go into the discussion about formative and reflective, but this would be my 0 minute, so I should stop now. Thank you for your attention.
Thank you very much. And again, no formal discussions, but questions and comments are welcome. Yes, Chris.
Thank you, Peter. That's really, really interesting, and I think that's huge progress. Because I always thought that these requirements for metric, Scala, configural invariance, and the strictness that are formulated to find this in a set, you have 30, 40 countries and you make this a requirement to find this in every group, this is so highly unrealistic. And the fact that it couldn't be found with the original Schwartz setup, which was designed to maximize the dimensional structure, which emancipative values were not, and you still couldn't find it, is actually an outright proof of how unrealistic these assumptions are. So I think it's really a big step forward to leave behind these unrealistic assumptions and open this up for a little bit more leeway and look for approximate rather than exact invariance structures. So I like this a lot. The other thing, if you look at this, you will probably agree, this requires such an enormous effort of computational power. Running these things, the computers are running for several days. An enormous effort also among scholars to think about how can we get items into the batteries that are more interchangeable. And a lot of energy is focusing on the measurement part of our models. At one point, I think we need a cost-benefit analysis, and for that, I think you need an external, an outside criterion. Because I see so many papers. You are exempted from that accusation, but I see so many papers which you see nothing else published than discussion about a measurement model. And it consumes so many energies.
Especially in psychology. It's one way to make a career.
I just cannot believe this. And no one ever asked, does it actually matter? So what one should do is, one should look if one has achieved with the new item battery, after the revision, it now gets better measurement model scores than before. One should look if it's getting better predictive power on the same dependent variables than before. Because if it doesn't, I would almost say it's not worth the effort.
I think one has to do both. The question is, when we have a circle, we have to say you have to invest. You have only 100% of your time available. What is ever 100% a week? Depends on the individual situation. And so I think in psychology has been really over committed to measurement and have neglected theories very often. In sociology, political science, it was the other way around. They ignored measurement, they were rather naive. At least when I did the German scale handbook, I was wondering every day when I did the work what people did in measurement, because it would not need so much time sometimes to do it. It needs a lot of time to do good measurement, to think about it, and it's a theory-driven job also, when one does it in a good way. So one should have let's say, a sound relationship between them. I don't say it in percentages, so I think it's good to invest in it. And one way maybe is also to improve the training, because when people get used to it, they can do such analysis very fast. And I mean, the higher school is investing in it in the curriculum. one of the few in the world so far I know. I know that we have proposed, for example, to Giessen to make a course on these topics this year first time, and it was well accepted. But Giessen also never did it, because it's rather new, and I think the point is that you have to learn it fastly and learn the technique, then it will not need so much time. But one has to do it not only once, because then one forgets all the details again. So that's a more pragmatic argument. So, but I still think, like with validity theory, you need both because of these possible biases which take place. But I think at the end is, even in psychology, people talk it construct validity, what you are referring to, and this was one of the most famous papers by Kronbach and Mehl. They looked at a prediction. Are we really, can we predict something? Not only maximizing the internal structure, but one needs both. Okay.
Thank you. Jan.
I wonder whether it would be possible to have on the screen that slide with that latent variable model and 3 indicators.
The first one or the first one?
Anyone.
Yeah, anyone. Okay. I think here for universalism I had no to have less time. I need some time. Sorry. But maybe you can formulate your argument or your question. I work hard to get it.
There was
one.
What?
You missed one.
Oh, here it is.
Well,
Sorry.
yes, I just wonder about these items. These
Yeah.
are these categorical items with categories leveled from 0 to 10.
No, I think in the ESS this was 1 to 7.
Yes, well, these are not items, this is immigration.
Yes.
So 7 is in the Schwarz battery. But whatever it is,
Yeah.
I just wonder about some tacit assumptions here.
Yeah.
You seem to be assuming that such an indicator with categories from 1 to 7 is what? Normally distributed? Is a metrical variable?
You mean the indicator or the latent variable?
Well, I'm talking
Indicator,
about
right?
the distribution
Yeah.
of these indicators,
Yeah,
since
yeah.
you have kindly pointed me to the site that informs about this data.
Yeah.
Well, then you are assuming that these 3 variables are jointly normally distributed and you follow with your analysis. But this is a very controversial assumption. For instance, I remember that many years ago, Karl Jöreskog has introduced a program called Prelis, and one was supposed to use this Prelis before using Lizard. Prelis has very nice tests for normality, and I think these tests would refuse the tacit assumption that there is a joint normal distribution here, because what we really deal with is a 7 by 7 by 7 contingency table, and it's very difficult for such data to be jointly normally distributed.
Yeah.
So my suggestion is, you could, if you really want to use these schemes, let's call them Jöreskog schemes, you could use a Norwegian export product. Anders Skrøndal has extended these simultaneous equations to the situation when we deal with categorical variables, and the link between those various other things in there is generalized linear model. And these tools for this are available. And I would like to add something from myself, namely, if there is assumption that a particular categorical variable is normally distributed, let's say with equal intervals between 0 and 10, then we have a relatively little known test by Lindsay and Mesh, published in Computational Statistics and Data Analysis, that allows us to test directly whether there is a fit or whether there is no fit. And if there is no fit, everything which follows from the tacit assumption should be looked at very cautiously, because these are just indications. These are not derivations on the basis of something that is true.
Yeah, I try to answer. You refer to a very important issue, it's true. Because of the complexity of the analysis. Normally, I didn't do this. I have tried it out in M+, but also in other programs. We have now this maximum likelihood robustified, which does not assume any more normal distribution of the observed variables. It's called MLR, maximum likelihood robustified, and this is one way to handle your first or your second problem, which you rightly refer to. But we have here used maximum likelihood because of the complexity of the task of this many analysis. Maybe we should replicate it for maximum likelihood robustified, because it's easy to do in principle, and it solves at least the problem of the multivariate normality assumption, because it doesn't assume. And I think, when I remember correctly, Satora from Barcelona, he had shown that I think mainly the standard errors and the chi-square test is biased if the multivariate normality assumption is violated, but not the point estimates. So that's the reason why they developed this MLR. It's a correction with a correction factor estimator. So this is one way to handle it. You are right. The second one is we tried with ordinal also, because reviewers said it also, and I had done it earlier. The problem is that the computation broke down. Yeah. Because when you have this ordinal algorithm with polychoric correlations, where you assume latent continuous variable and ordinal measured variable, then the computation is extremely, let's say, complex. And when we have such a, let's say, complex model, it broke down. And I think nobody has done it in the world till now. I think all the examples I know with ordinal variables are mainly with 3 or 5 or maybe 8 variables, but one sample. And only if, but when you start with, like in cross-cultural research, to have a lot of samples, then it seems to come to numerical problems. So this was my problem. We had one try, we compared Belgium, Luxembourg and the Netherlands in a paper, and there the difference was not so big, but later on was a bigger one. But we've tried, and it's often has a problem of that the algorithm breaks down. Sorry.
We are running out of time, but I will ask one more question. So you lost out of 90 groups, 17 groups, right? Because
yes.
You were down to 73.
In the last example, with universalism.
I suppose you looked into those 17 to find out the problems. I'm curious to hear.
I'm still doing this because now we have. This is referring to another, let's say, learning effect from failure. You see, all this is inspired by failures, this research to a certain extent, because there were problems, and so we tried our new procedures and so on. And the one thing is, we are still thinking and discussing it. Was not so obvious, but one way, and this is a new type of research. Susanne Jaak, she is in Utrecht, started it with multi-level analysis, and I think Hermann Dülmer, and we have one paper on it, to use multi-level analysis, contextual variables, to explain why, and this is an interesting issue now for you also, for your research agenda, I think, because it's nobody has done it till now, only 2 papers, and it would be interesting to see from a cross-cultural point of view why certain loadings are not equal, and not only say it's a problem and stop, but using multi-level analysis to, maybe it's depending on the percentage of immigrants that they understand less well, maybe certain items, or it's a human development index, which we, in one case for universalism, we found differences in the Scala. So this is one way, but here I still have no solution. I have not.
Is there at least a pattern in the distribution of these time points and countries? Are they exist in Europe, for instance, early waves or something?
No, it was not so clear. That was my problem.
Not clear pattern.
They are not a clear pattern, and it would have been more straightforward. Right? Look at it. But it's a very interesting question, because it shows again that we should not only look at it from a technical point of view, but also from a sociological point of view, just trying to find explanations for it, and then use statistical tools.
Okay.
Maybe one more question. I did this actually with the coherence strength of the man-split values as a dependent variable, because they vary. And you found that some measure of cognitive mobilization would explain it. So you get more coherence in societies where you have more cognitive mobilization, which makes a lot of sense because these invariances also show us a little bit conceptual maturation of the sample that we surveyed.
So one can say one can use the theoretical ideas about certain contextual variables also not only for explaining certain things like attitudes, but also for explaining the responses, differences of people. And this is a new area of research, more or less, or not a neglected one in cross-cultural research, which you can use. You can use multi-level analysis for this and so on.
Okay. Well, we have to stop here, but very interesting. Thank you very much.